We're going to bring up Joy Dunn, who's going to represent SpaceX and take us to a whole nother level, thinking about space exploration.
I like high fives. There you go. All right, how's everyone doing today? All right. It's a little hard to see up here, but can I get a show of hands of how many of you grew up watching sci-fi movies or TV shows like The Jetsons? All right. And keep your hand up if you thought you would see flying cars or spaceships on other planets by now. All right. Well, the good news is that the future of space exploration is closer than you think. So before I get into some of the technology that my company SpaceX is working on, I want to tell you a little bit about my story. I've been a space nerd my entire life. I grew up building rockets since the age of 5, and I've been insanely driven by this passion to reach for the stars and to send things into space. And I kid you not that this quote is actually from my high school yearbook. I took that passion with me to MIT, where I graduated in 2008, and I've been at SpaceX ever since. In my 7 years there, I've gone from a development engineer to a manufacturing engineer to a lead, then a manager, and now the senior manager of our Dragon spacecraft manufacturing engineering team. But I prefer my informal title. Thank you. But I prefer my informal title of Mother of Dragons. So, to date, we've launched 8 Dragon spacecraft into orbit, including the very first private spacecraft to orbit around the Earth in 2010. We were also the first commercial company to travel to the International Space Station, and some of the cargo that we've delivered to the NASA astronauts on board have included our very own mousestronauts, plants to help test out food growth for long-duration missions in space, a 3D printer to actually print tools you can use in space, and probably the astronauts' favorite, ice cream. And I'm talking the real frozen stuff, not any of this astronaut ice cream. And as you probably figured out, I still want to be an astronaut when I grow up. So for SpaceX's story, one of the key enablers to the future of space exploration is reusability. To give you an idea, think about how expensive it would be if you needed to build a new airplane every single time you flew from New York City to San Francisco. The cost would be so outrageously expensive that only the mega billionaires would be able to afford air travel. This cost barrier still exists for space travel, but reusability will dramatically cut down on that cost of access to space. And it'll allow for much quicker turnarounds. Think if you could have a rocket launching people to space every hour, just like you see a plane taking off from SFO every few minutes. In both of these pictures up ahead, these are real-life tests that SpaceX has done for reusability. The picture on the left is our Falcon 9 rocket attempting to land back on Earth after successfully deploying a customer satellite into space. By reusing this portion of the rocket, we're able to save a considerable amount of the cost per flight, and we're able to refly after adding on a second stage, running some checkouts, and refueling just like an airplane. And the picture on the right is our Crew Dragon test vehicle performing a hover test to simulate landing back on Earth after a successful mission, and potentially landing on another planet someday. With both of these technologies unlocked, we'll be able to make life multiplanetary. And you certainly don't have to build a new spaceship every time you want to fly home from Mars. So in case you haven't figured it out now, SpaceX launches and builds rockets. We were founded in 2002 with the goal of revolutionizing space technology with the ultimate goal of enabling people to live on other planets. We've had 22 successful launches to date, and hopefully our next one in just a few days from now. So this is from our launch pad in Cape Canaveral, Florida. And you can see as the rocket takes off, at the very bottom of the rocket, we have these mechanisms called landing legs. Close up here. Here's close up right there. So these landing legs will actually open and deploy to allow us to touch down back on Earth. Before we test it out on a flight vehicle, we always do a test vehicle as well. This is our Falcon 9 test vehicle in Texas, performing a vertical takeoff, vertical landing test. So this is a single engine test instead of the 9 engines per our normal Falcon 9 rocket. And you can see it over the fields in Texas right here. And as it's coming back down, a nice soft landing. One of SpaceX's other main products is the Dragon spacecraft. That's what I work on. And here we are about to dock with the International Space Station to deliver some cargo. And this is my favorite part.
And capture is confirmed.
Our next goal is to build a crew vehicle, which will actually keep people into space next year. And to run a test for that, this is our Crew Dragon abort vehicle. It's performing an abort test to simulate sending astronauts off to safety in case something goes wrong with the flight. If we don't use those engines, for an abort scenario, we can actually use them for landing back on Earth or another planet. And one of my absolute favorite launches, this was in December last year, only 2 months ago. We successfully deployed a customer satellite into space and then brought our first stage of the rocket back down to Earth and landed on land. So next stop, Mars. All right, so how did SpaceX get here, and how can you apply some of this to your own business? First and foremost, always question the status quo. SpaceX has a very Silicon Valley startup approach to aerospace, and we routinely take on and solve problems that other people deem impossible. In the top picture here, you can see the landing legs up close and personal on the bottom of the rocket, and in the bottom picture, you can see our grid fins, which actually pop out and precision steer us back down to our landing pad. When we first put these on a flight vehicle in 2014, people thought we were nuts. But here we are a year and a half later, proving them all wrong. We do this because we push the limits of existing knowledge and because we have a kick-ass team of people to get us there. SpaceX hires the top 1% of talent from a variety of industries, including gaming and automotive. And we actually have a saying in recruitment that you always want to hire somebody smarter than you, or else you're making the company dumber. Another one of our key enablers is quick iterations and quick turnaround. We can do this because we have direct interaction between our design engineers and the production floor. They literally only sit a few hundred feet apart from each other. We also have a really flat organizational structure, so anybody in the company can bring an issue to our CEO, Elon Musk, if it's a potential risk for flight. And in order to enable these quick turnarounds, we do a lot of our own in-house manufacturing. All right. But no matter how much we're pushing the envelope, we're first and foremost always focused on building a safe and reliable vehicle that's also cost-effective. And we do this through our mantra of design, build, test, fly, and refly. On the design side, we work from first principles and not legacy solutions. The term flight heritage is not something you often hear around the office. And by first principles, I mean boiling something down to the most fundamental truths that you know, such as Newton's laws of physics, to help guide your design, and not always reasoning by analogy. We also want our design to have a really 21st century look and feel. You can see pictured here the exterior and interior of our Crew Dragon vehicle. We want this vehicle to be something sexy, something that you actually want to fly in, and we'll be sending people up in this next year. On the build side, 70% of our rocket is manufactured in-house. This allows us to have much quicker turnarounds, more cost efficient, and then also a higher control over quality. We also have a lot of commonalities in our vehicle subassemblies, so we can use the same material, the same tooling, and the same manufacturing processes so we can have rapid production. And in order to validate our design and our build processes, we do thorough flight-like testing at all stages of assembly. This can be anything from pressure testing of valve all the way up to full-scale vehicle testing, just like the Falcon 9 and Crew Dragon test vehicles you saw in the video. On the build side, we're constantly challenged to think of the bigger picture instead of the low-quantity immediate solution of today. When I first started at SpaceX 7 years ago, we were building one rocket and one spacecraft at a time, and now this is what our production floor looks like today. At the top, you can see our Dragon spacecraft assembly line. In the bottom left is our Merlin rocket engine assembly line, and the bottom right is our Falcon 9 first stage rocket assembly line. We're always looking to jump by an order of magnitude in order to innovate. We're looking for change. We're looking for how do we think outside of the box? How do we actually step above and beyond a solution that exists today? Later this year, we'll be launching one rocket to space every 2 weeks. Excuse me. But in order to do that, we're also thinking of the bigger picture. We're thinking of how do we build a fleet of even bigger rockets, of even more engines to get us to Mars. That is our end goal. That's what we're constantly thinking of. So we challenge ourselves by asking the question of what would it take to build and launch one rocket every week? What about every day? What about every hour? This gets us to our philosophy of fly and refly, and a world where reusable rockets and spacecraft landing on other planets is a reality and not just a science fiction movie. Thank you.